Okay, everyone, we are going to talk about the polar areas. Now, I hope that you can still remember on how to graph polar coordinates. It's because we're not going to talk about that here in our lecture. Hence, I'm just going to talk about how are we going to get the area of an enclosed region. So say for example, we have here find the area enclosed by one petal of the polar curve r is equal to sine 2 theta. So if you're going to graph that, it will look like this, no? It will have four petals. Guys, you can do in graphing again, you can let something value in theta and r to graph and to achieve this kind of graph. Now, if you're going to use the 0 degrees, 45 degrees, 90 degrees, do not let your calculator in a radian mode. Instead, you're going to use the degree mode. But if you're going to use the 0, pi, 2 pi, pi over 4, something with pi, now that's the time that you're going to use that in radian mode. Okay? So, sige, let's start. Again, the formula of finding the area of the polar coordinates or the region enclosed in a curve or in a petal here would be area is equal to 1/2 from alpha to beta. So meaning the angles from this right here. Okay. So from this kani diri. So since this is touched, this point up to this point here. So we will know that later. So let's just type from alpha to beta. Sorry, let's erase this one. This is not the correct one because it started here. So it started here, so 0, right? And then it ended here, somewhere there. So yeah, from alpha to beta, and then r squared, which is sine 2 theta squared d theta. Now the thing is our limits is not known yet, so we cannot integrate it yet. Okay, what is the limit? If we're going to use, or if you're going to use in radian mode, then this right here would be 0, and this would be 90 degrees, or that's pi over 2, right? Because pi is 180, so 180 divided by 2 is 90 degrees. So therefore, we are going to use or let our calculator into the radian mode. Okay? Careful with rad or degree mode, because back when I was college, there was a time I got 2 over 50 because my calculator was in radian mode. That's an exam. So you have to be careful. Okay. Now, we already know our limit, so that's 1/2 since again it started from 0 and ended with pi over 2. Therefore, that would be our limits sa isa ka petal. But if you're going to use the petal here from this point to this point, actually it's just the same, but the limit would be different now. So that's from pi over 2 up to pi. And I'm pretty sure you will arrive at the same answer since all of the petals here are equal. Okay, so that would be equal to sine squared 2 theta. Okay, if you guys remember the trigonometric identities in which we call the power reducing half or half angle formulas. So let me show you that one. To make our to make it na ma-integrate. Ay, sorry. So yeah, this is very useful, no? And I believe I have used this on our first quiz. Uy, sorry, forgot to theta, d theta. So if we have sine squared u is equal to 1 minus cos 2u over 2, therefore sine squared 2 theta will just be equivalent to 1 minus cosine 4 theta over 2. Okay? And then, do not forget d theta. Okay, so now we can easily integrate this one. So that's area is equal to 1 half. Oh, 1 half times what? That's 1/4. Then, ang mabilin is 1 minus cosine 4 theta d theta. Okay, so let's let u is equal to 4 theta. D is equal to 4 d theta. Divide both sides by 4. So that's d over 4 is equal to d theta. Let's change that. So 1 minus cosine u d over 4. So this one is d theta. Okay. All right. And then that would now be equal to 1/4. Then d theta is, the integral of d theta is just theta. Then integral of cos u is sine u, in which u is 4 theta. So sine 4 theta over 4. Okay, our limits would be from 0 to pi over 2. All right, now substituting, that's higher limit minus lower limit. So 1/4 times pi over 2 minus sine times 4, sine 4, sorry, times pi over 2 all over 4. Okay, then minus 0. Sine 0 is always 0, right? So that's 0 minus 0. So therefore, that's 1/4 times pi over 2 minus sine. Okay, again, gawin nating rad yung ating calculator. So that should be in radian form, our calculator. So press shift mode and then rad. Then sine 4 times pi over 2, that is 0. So therefore, sine 0, 0. So what's left here is pi over 2. So pi over 2 times 1/4, that's pi over 8 square units, in which this is our final answer. So therefore, the area of a petal here in our graph is pi over 8 square units. If the question would be find the area of the 4 petals, and you just multiply this one by 4. So that's 4 pi over 8, or uh, pi over 2, right? Okay, so let's proceed with the other example. Find the area enclosed by one petal of the polar curve r is equal to 2 cosine 3 theta. So again, the graphing part will not be discussed here, but you can let values of theta and you can get the values of r, and then you can plot it. So just remember that this is pi, because 0. Then this is pi over 2 because that's 90 degrees. This is pi because this is 180. And 270 is pi over 4. Pi over, wait, 3 pi over, wait lang. 270 pi divided by 360. That's 3 pi over 4. Okay. All right. So to find the area of, and then the whole 360 degrees, that's 2 pi. So finding the area of the enclosed, the region bounded by one petal here, which is this one, it's just similar. No? So area is equal to 1/2, then alpha, beta, r squared, d theta. Okay, the problem is what would be our limits since we touched, we started here from Kane, from this region, right? And also from this. So it's kind of complicated, right? To find the limits of this um, curve or petal rather. So how do we do that? How are we going to find it? So guys, remember that this is cosine 3 theta and this is 2, which is the radius. Okay? So how are we going to look for the limits? If we're going to divide, diba, this is Cartesian plane, so kanisha is 90 degrees. So that's 3 theta in our equation. R is equal to 2 cos theta, 3 theta. So 90 divided by 3, that is 30 degrees. Why did we divide it by 3? Okay, so we are going to use our intuition or our common sense, maybe. So in 0 to 90 degrees, we divide it by 3. Tama. So 30, 60, 90. And cos 3 theta is given. So therefore, this is 30 degrees or that's pi over 6. And obviously this one is negative pi over 6. Okay. So again, 30 degrees and negative 30 degrees. Okay. Again, pag you are going to cut that into 3 pieces, that's 30, 60, and 90. Okay. Therefore, we can now get the area. So that's area is equal to 1/2 times negative pi over 6 to pi over 6. And then 2 cosine 3 theta squared d theta. Simplifying, that's 4 cosine squared 3 theta d theta. Okay, we're going to use again the power reducing or the half angle formulas. So this is the power reducing formula. So let's reduce this power into half angle. So that's 1/2. So ilabas na lang natin si 4. And then cos squared 3 theta. So if cos squared u is 1 plus cos 2u over 2, then ang 3 would be equivalent to 6, right? So therefore that's 1 plus cosine 6 theta all over 2 d theta. Okay, can we integrate it now? Yes, we can. So that's 4 over 2 is 2. 2 over 2 is 1. Therefore, the constants will now be gone. So area is equal to, sige, from negative pi over 6 to pi over 6, and 1 plus cosine 6 theta d theta. Okay, so we can separate them, no, para mas dali. Pi over 6, then pi over 6, then d theta or 1 d theta plus negative pi over 6 to pi over 6, then cosine theta d theta. Okay, so that would be area is equal to theta, in which the limit is from negative pi to 6 to pi over 6, plus what is the integral of cosine theta? That's positive sine theta. So that is from negative pi over 6 to pi over 6. Okay, so therefore this is pi over 6 minus negative pi over 6. So that's plus pi over 6 plus sine pi over 6. Let's use our calculator. I'm sure that would be 0. No, it's not. So sine pi over 6 is 1 half. So I was not sure pala, no? Sa di ay. Then sine negative pi over 6. Oh, yes, ma-0 Japon siya. Because this is minus 1 half. So sine negative pi over 6 is negative 1 half. So that's 0. Therefore, our area is 2 pi over 6 or pi over 3 square units. This is our final answer. Okay, for number 3, find the area of r is equal to 5 plus 2 sine theta. Okay, so if you're going to graph that one, it would look like this. Okay, so this one is kaning mga points here is 5. Kung asa siya na i-add to, no? This one again is negative 5 as well. And this one is 2 minus 5, no? 2 minus 5 is negative 3. And this one is 7. 5 plus 2, so positive 7. So it's like circle but not a circle. Mura lang, no? Pero it looks like a perfect circle, diba? I'm so magaling with graphing. I'm sorry about that. I'm not good with um, plotting curves, especially if dili siya graphing paper. Reasons. Okay, let's find the area. So area is equal to 1 half and then the limits alpha to beta, then r squared d theta. Okay, the whole circle or unsa ba ni siya. Okay, it started from this point. So this is kani siya, 'di ba, is 0. Then it rotated until so pak back to 2 pi. So therefore it's from 0 to 2 pi. 1 half, so 0 to 2 pi, or that's 0 to 360, 'di ba? 0, 90, 180 to 70, 360. So bumalik siya sa 360. That's why that is our limit. And then this one is 5 plus 2 sine theta squared d theta. So that's 1 half. Let's use the FOIL method to distribute. 5 plus 2 sine theta squared. The result would be 25 plus 20 sine theta plus 4 sine squared theta, then d theta. Okay, for me, I will distribute this one para mas madali, no? For us to integrate it easier, in an easier way. So that's 1 half from 0 to 2 pi, 25 d theta plus 1 half. Okay, so that's 20, no? Sine theta d theta plus 4 over 2 integral of sine squared theta d theta. And that is from 0 to 2 pi, 0 to 2 pi. So therefore, that's 1 half 25 theta. 25 theta plus, so that's from 0 to 2 pi, 10. This one is sine theta is negative. So negative cosine theta. So this is from 0 to 2 pi again, plus 2. Then sine squared theta, let's use the half reducing formula. So, sorry, the power reducing formula. So, kani, see sine squared, that's 1 minus cos 2 theta over 2. So 2 times 1 minus cos 2 theta over 2. Then, ay wala pa din siya na-integrate. Sorry. That's from 0 to 2 pi. Then d theta. Okay. So let's not So let's rewrite it first. From 0 to 2 pi. And this one is plus or sige, plus 10 times negative cosine. I did not distribute negative para mas easier ang transitioning later on. Pi. Ngayon siya is plus 2 and 2 wala. So what's left would be d theta plus, or sorry, that's minus cos 2 theta d theta. 0 to 2 pi, then 0 to 2 pi. Okay, so again, let's write. Sabay na nato sila, no? Let's change the values of theta into 2 pi and 0 later on, no? All together. Sabay na nato sila. So from 0 to 2 pi, then this one, copy again. Then this one is theta, then 0 to 2 pi minus this one is we let u is equal to 2 theta, d over 2 is equal to 2. Sorry, it's equal to 2. Sorry, it's equal to d theta. So therefore, that is sine 2 theta all over 2 from 0 to 2 pi. Okay, so now let's change the values of theta into the limit. So 25 times 2 pi all over 2. So minus 0. So obviously this is 0, diba? Plus 10 times negative cos 2 pi minus 10 times negative cos 0 plus the third term, which is theta. So that's 2 pi minus 0 minus the last term, it's sine 4 pi. Actually, that's 0. No, sine 0 is 0. So sine 4 pi would be 0. So that's 0 minus 0. Okay, simplifying our answer would bring us to this one is 25 over 2. So 50. Ay, makancel di is 2. So 25 pi. Kanisha is 10 times negative cos 2 pi is 1. Okay, so that's negative 10 plus negative 10 minus cos 0. Ay, sorry. Okay, so minus negative 10, so that's plus 10 plus 2 pi minus 0. So kanisha, negative 10 plus 10 is 0. So therefore, 25 pi plus 2 pi is 27 pi square units. It's our final answer. Okay, so that's it for our lecture for polar areas. I will be giving you activities or quiz on Monday and exam on Tuesday from the volume of ito, Solids of Revolution and the polar areas. Okay? So quiz again on Monday, and on Tuesday we'll be having our exam. So good luck about that. Thank you for listening and have a very good day. Bye-bye.